Good morning, students. Today we learn about the operating system design and its implementation. So we'll see design and implementation of the operating system structure, building and booting an operating system debugging. So the objective includes the compare and contrast the different types of operating system, illustrate the process of booting an operating system, apply tools for monitoring the system performance, and design and implement kernel modules for interacting Linux kernels. So, and implementation of OS is not solvable, but some approach have been successful. So, internal structure of the different operating system can vary widely. Start the design by defining the goals and specifications affected by the choice and type of the systems. The user goals include that the operating system should be convenient to use, easy to learn, reliable, safe, and fast that all of us wants. And the system goal includes the operating system should be easy to design, implement, maintain, as well as flexible, reliable, error-free, and efficient. Specifying and designing an OS is highly creative task of software engineering. So policy includes like what needs to be done, and mechanism includes how to do something. Okay. Then for implementations, we can use different variations, different languages, and we can use emulation that how it will perform. The structure of the operating system includes like simple structure like MS DOS, more complex structure like Unix, layered structures or microkernels. So a monolithic structure like original Unix, it is limited by hardware functionalities, and original Unix operating system has the limited structuring like some system programs and the kernel. This is the structure of traditional Unix system. At the level, we'll have some interfaces like signal terminal handling, character IO systems, file systems, CPU scheduling, paging, virtual memory management, disks management, etc. Above that, we'll have some shells and commands and compilers and interpreters and libraries. So with the help of that, we can use or call the kernels, and from the user end we'll use these cells and commands to communicate or to do work with the kernels. So we'll use the system calls from applications that particular service will be called, and accordingly its related device drivers and hardwares will be called. Similarly, we can have a layered approach also. We can have different layers of operating systems. Then some microkernels, like it is like a kernel, but it is into the user space. So benefits are easy to extend, e- easier to port, more reliable, and more secure. Limitations are performance overhead of user space, as it will be a part of the user space. Okay, so we'll not see in the more detail. Then modules and some hybrid system combination of all these. This is for Mac OS. This is for Darwin. This is for Android. So in Android, there are some additional things like ART virtual machine, that is Android runtime virtual machine, then Android frameworks and some native libraries, etc. Thank you.